Good morning, folks. Jim Giacchetta here. I'm the CTO of VidOvation Corporation. I think we'll get started. We have a good number of people logged in, and we'll get started. If you have to step out or the phone rings or there's an emergency, we will be recording today's session, and we will be publishing the recording of this webinar. So let's get started. So what is today's webinar about? What is Perseus? Perseus is a new codec, a new compression standard that has been introduced by our friends at Vinova. And what is the purpose of Perseus? One of the challenges with any kind of transmission, whether it's for contribution or distribution, with more and more video streams being transported, with more and more transmissions being IP, doing more at-home productions, REMI productions, etc., we constantly need to lower our bit rate. Bandwidth costs money. Bandwidth is not free. Now, there's different levels of bandwidth. Some of our other products, we use the public internet or bonded cellular a lot. With the Perseus codec, it's more for contribution or a mezzanine type compression. This is more for a managed network. So this is going to be a higher bit rate, a higher quality, analogous to JPEG 2000. So you'll see some comparisons between Perseus and JPEG 2000. So the challenge is lower the bit rate. We all want to, in an ideal world, have compression where we can't see any of the artifacts. Similar to a JPEG 2000, a Perseus codec has minimal losses or near visually lossless transport, which is ideal. And another advantage or another pain point is we all want our IP transport to be as close to zero latency as possible. And then we want the flexibility in our IP transport for different types of workflows, signal flows, to support at-home productions or REMI productions where we don't have a truck in the field anymore. We home run all the cameras back to master control, and we do our workflow in a central location. So Perseus solves some of these problems. Traditional systems now, most manufacturers are focused on a JPEG 2000. JPEG 2000 has been around since the year 2000. It's in widespread deployment. But now as we migrate to 4K and UHD, JPEG 2000 really was designed more for HD, or the transition from SD to HD. Now, as we all know, we're seeing bandwidths increase fourfold. A UHD or a 4K image is equivalent to 4 HD signals, or 4 times the bandwidth. So we need to economize or minimize some of that extra bandwidth that's needed, that extra bits that we have to purchase. So this Perseus, and I should say Perseus Pro, because there is a Perseus Plus variant of it, but today we're talking mostly about the Perseus Pro and the contribution grade codec. So similar to JPEG 2000, it's an intra-frame compression standard. In other words, it compresses inside of a given frame. There's no compression across frames, or a group of frames, or a group of pictures, or a GOP. So as a result, you get a higher picture quality. An intra-frame standard is probably going to be a higher bit rate than an inter-frame, such as H.264 HEVC. So everything in engineering, there's always going to be trade-offs. So Perseus gives us a flexible intra-frame encode decode. It gives us a higher quality along with a higher efficiency. In side-by-side tests, we can see savings anywhere from 25 to 80% in bit rate or data savings, while still maintaining, in most cases, even superior quality. So usually that's lower bit rate usually means lesser quality. So it's a more efficient codec, particularly efficient at 4K and UHD. So what is this compression standard? What is the mechanism behind it? A JPEG 2000 is a wavelet-based compression system. Perseus uses what's known as a hierarchical or multi-scale image representation. So what does that mean? That's a mouthful. I can barely say it. Hierarchical multi-scale. So what does that mean? It means that instead of wavelet, what it does is it downsamples the signal or downsamples the image. So if we're starting with a 4K or a UHD image, one of the first downsamples or downscales would be to 1080p. Then a level below that might be 540. And there's actually 15 levels of downscaling or down conversion in Perseus Pro, which is great. That sounds like how compression works. We're minimizing in some way. We're compressing the image. But what it does very interestingly is it up converts. So each of these 15 levels, it down converts to each of these steps, then converts it back, and then looks for a residual or an error. So it compresses, it down converts, and then it has this error information or residual information, which allows it to maintain almost perfect or near or visually lossless compression. So it's a contrarian methodology to wavelet. It's also a very quick process. These downscalings and upscalings happen in parallel. So the throughput is very quick. So hence the latency of Perseus Pro is much less than some of the other standards that are out there. We have VNova actually has a very nice, for those of you that really want to dive into the standard, Perseus has a very nice white paper on the subject of this hierarchical multi-scale codec, which we'll put on our website in the notes of the webinar when probably later this week or next week. So for those of you that want to dive deeper into that. So how is Perseus implemented today? So Perseus Pro is implemented in a product made by VNova called P.Link. And P.Link, as I discussed, the P.Link uses the Perseus, the intra-frame only compression. Gives us visually lossless, higher efficiencies and better video quality. By efficiencies, we mean lower bit rates, and better quality, we're meaning you don't see the artifacts or the visually lossless. I have a bad habit of spilling the beans on future slides, but on a future slide, I'll mention also that all compression artifacts are not the same. Some of the other standards, when they start getting blocky or banding, Perseus, the artifacts are softer. You don't see any harshness when at lower bit rates. So it's a more forgiving compression, which helps to maintain this better video quality, more appealing to the human eye. The other thing that's great about these boxes here, these P.Link boxes, is if you feed them house reference or Genlock, you can maintain perfect video and audio lip sync tens of thousands of miles away. You can do a multi-camera REMI or a multi-camera at-home production. Have cameras going in both directions. So the box basically has 8 I/Os. So 6 of the I/Os are 3G SDI compliant, and 2 of the IOs are 12G SDI compliant. So you can do 2 HDs or 8. I'm sorry, 2 UHDs and 8 HDs, either or a mix and match. You know, you could have a 4K coming in the field and 4 HDs coming back. You can home run 8 cameras. Again, this is over a managed network. You know, the typical bit rate on a stream is about 125 megabits per second. It does operate at lower bit rates, but this is meant for a managed network. You know, you're going to need a telecom connection, a fiber, etc. You know, something with a service level agreement. This product or this standard is not designed, as I said earlier, to go through the public internet or to go over bonded cellular. Different applications, different animal. So the IOs are bidirectional. So with software, we can turn an input into an output or vice versa. So that gives us tremendous flexibility. You know, if there's last-minute changes in your production workflow, hey, we need 1 more camera, or we need to return 1 more program feed back for the talent at the venue, we can flip a channel around. And you use 2 of these P.Link devices, 1 at each side. So one might be out at your golf course, and the other appliance would be in your master control. And of course, you can gang multiples of them together. So it has some unique features that help with this at-home production workflow. So it's got some dynamic multiplexing, so we can assign the amount of bit rate that we want to give to each video, and I'll explain how that will benefit. But you know, so you could have if you're home running all your cameras to master control, really the camera that's hot, that's being broadcasted is the only one that needs the maximum bit rate. If a camera's on standby and a director hasn't taken it, but I have a slide that'll get into that. And you can control adaptively the bit rate, and that dovetails into this workflow, REMI at home type workflow. Then it does have this full frame mode where if you have interlaced content, it does some trickery behind the scene. I think what it does is it converts it to progressive and then down converts, so you get some further economy of scale, in particular if you're doing interlaced. I see this product being used a lot in sports, and you don't see a lot of sports being shot in interlaced. So I'm not sure where this feature would come into play. You customers will tell me how that might help. There'll always be circumstances where maybe you're doing 1080i and you could gain this extra 30% savings in bandwidth. So here's this adaptive bit rate. This is a slide that kind of shows it a little better. So we're doing an at-home production. So there's no truck or a minimal truck. Maybe there's more of a van with maybe a video engineer shading cameras. Another interesting thing about the Perseus and P.Link, the latency is extremely low. It can get down to 150 milliseconds or less. And you could shade a camera with that kind of latency. Now, that would be the round-trip latency. So the camera shader could sit in master control thousands of miles away and shade the cameras remotely. But, you know, in the example I'm describing, so there's a smaller van, a smaller presence at the show, at the venue. We home run all the cameras. Now, you know, if you have 10 cameras, or, well, 8 cameras, you know, only one of them is going to go live at a time. So why have 80 megabits? You see in this example we have, let me turn on my little laser pointer. We have 80 megabits per second on the program feed. The TD is selecting the camera he's going to take next in preview, and then these proxy feeds could just be, you know, for the multi-viewer, so that the director can see what shots he wants to take. So you can see through an open API that hooks into the production switcher, or through GPI contact, some sort of handshake between the production switcher and the VNova P.Link platform. When a camera enters preview, the bitrate can be jumped up from 10 to 60, and then when the camera is taken from preview the program, and within a couple of frames, it's that quick. It will jump up to the higher bitrate. Or certainly, a director never takes the camera straight. He's always going to preview it. You go camera 2 ready. You put that, it enters preview. Camera 2 now jumps from preview to program. Then he's looking for his next shot. Okay, camera 4 ready. That enters preview from the proxy. So you could see how this workflow might work. Again, this is assuming you have some constraints in bandwidth. If you have enough bandwidth, you wouldn't need to multiplex or adaptively change the bit rate. But you can get the idea that you can do some clever techniques to minimize your bandwidth for production or for contribution or for at-home production in particular. Then other things that maybe here they show in this scenario, we show a stream coming back. So we're doing a golf tournament, and there's some talent in the studio and there's some talent on site. So we might want to send the analyst, the talent at the venue a stream. Doesn't need to be super high quality. They just need to see the anchor or the talent in the studio. They just need to see the program feed to see their cues when they're being questioned or their Q&A. So there's a myriad of scenarios where you can change ins and outs and adapt the system to your workflow. So P.Link, again, for contribution for a managed network, it's a high performance intra-frame, within a frame contribution codec. The benefits are it maximizes the use of your existing infrastructure, so you can migrate easily from HD to UHD. Very flexible software, as I've shown. It helps you to support different workflows. It has an intuitive based GUI, and it integrates with your network management system, so it seamlessly can drop into your existing infrastructure, all with a nice open API. Of course, any of you that are interested, we can set up a demo with our partner VNova, set up a demo through VidOvation, get you folks to play with some of this stuff. Then another nice thing too is it doesn't run on a proprietary piece of hardware. It runs on a carrier grade, commercial off-the-shelf server. It's got hot swappable power supplies, cooling, very low mean time between failures. It's a very reliable carrier grade appliance, which is perfect for our mission critical content or contribution coming in from the field. So here's a little snapshot of some comparisons. So lowest bandwidth, its flexibility and bidirectionality, compared to JPEG 2000 with its more rigidity. I don't think JPEG 2000 is going away anytime soon. There's a big footprint out there. But if you're looking to modernize, or particularly switching from more of a on-site production to an at-home production, a REMI production, the Perseus Pro with implemented in P.Link starts to make a lot of sense. And another thing too is, VidOvation, we represent solutions for H.264, HEVC. These solutions are primarily for unmanaged networks, but they could go over managed. Picture quality is good, but a mezzanine codec like Perseus Pro, a higher bit rate, lower latency, is going to give you higher quality. So, if you're the primary rights holder on a function, you want the best possible quality coming into the field. And because, unlike a temporal codec like MPEG or like H.264 or HEVC, because we're only compressing in one frame, not across frames, we don't have a group of frames or a group of pictures like these other standards. temporal or motion distortions or anomalies are minimized. I'm sure many of you know the difference between intra-frame and inter-frame. But if you have motion here, here's a little diagram. It looks like somebody's got a ping pong mallet with a ping pong ball, and you see the only thing really moving in the frame is the ping pong ball. Now, if we're using Perseus or an inter-frame codec, you could argue, look, none of these pixels in the frame have changed, so why do we send the same frame essentially the second time, the third time? Well, it will, you might, in an MPEG format or a temporal codec, you might start seeing some motion artifacts around the moving object, some scalloping of the leading edge of the moving object, whereas you won't see that in an interframe MPEG standard. So you see here in an interframe, you only send the information that's changed, so you don't send all these bits. So that's why H.264 and HEVC can do much lower bit rates. But again, in engineering, it's that trade-off. How important is this content? Are you going to be archiving this content and using it over and over again for highlights, etc.? So it's different applications. Not every production can afford the unmanaged network to use a transport like Perseus or P.Link. So again, VidOvation helps our customers navigate some of these decisions of what type of technology to use. But in a nutshell, it's the Perseus, the intra-frame, it's going to give you much more consistent quality. We all know that shot over a sea of faces in basketball, or the tiny white ball over blades of grass in golf, the quick pans, the quick zooms, those can challenge H.264 and HEVC codecs, where a Perseus intra-frame can handle that type of more challenging content, high motion content, and offer lower latency. HEVC and H.264, because we have these group of frames that we're compressing across, or group of pictures, or GOP as we call it, the latency's got to be at least as long as the GOP. That's the theoretical limit. By being intra-frame, we can get very aggressive on the latency and minimize any kind of temporal distortions. So a common question we get is like, okay, this is some new standard. What happens if we adopt it and it goes away? Or so one of the common questions we get, is it a SMPTE standard? And it's in committee right now. The project is named VC-6. The pending designation for the standard is ST 2117 or 2117. In the future, it's anticipated that you'll be able to buy off-the-shelf decoders that conform to the Perseus compression standard once it becomes standardized and ratified by SMPTE. Again, some of this I'm kind of being a little bit redundant. Now, I did talk about, it's meant for managed networks for higher bit rates. It is able to go at lower bit rates. It does have that ability. When you compare Perseus at lower bit rates to JPEG 2000 at lower bit rates, in side-by-side visual tests, the Perseus looks much better. When compression artifacts do start to appear, they tend to be less harsh, no sharp edges, it's very hard for the untrained eye to see the compression. And again, the flexibility of the platform, to do different types of productions. One takeaway is the Perseus is so efficient. It can handle a 4K signal with the same bit rate as a HD signal with JPEG 2000. So it does have that 4-to-1 or 75 or 80% more efficiency compared to JPEG 2000, which I think we all need with 4K on the horizon, or just to save bandwidth costs, because you're going to need that unmanaged network. Now, if we can buy that pipe with a nice SLA, service level agreement, get a nice solid connection, maybe have 2 connections for redundancy. If we can cut the bit rate needed by 75%, that pipe becomes a lot less expensive. So that's important to all of us. So, in conclusion, saving the cost, lowering that bit rate compared to JPEG 2000. We all want our compression to be visually lossless, near lossless, and you get that with Perseus Pro, getting higher efficiency, higher video quality, and then maintaining extremely low latency, and then having that flexible signal flow, 8 ins, 8 outs, or any combination therein. You have those 8 unidirectional I/O ports, and then the ability to maintain gen lock and perfect lip sync across all of these cameras. We bring these cameras home to a centralized location. If they're all out of sync, then we're going to need 8 frame syncs and standards converters, etc. We want everything to come through. If it's a live show in particular, we can't fix video synchronization and lip sync problems in post-production. This is a live show. So the Perseus and the P.Link maintain all of that. So today I concentrated mostly on what's known as Perseus Pro. That's the contribution grade codec we see being used for production, a mezzanine type compression standard. I could even see this maybe being even used for archival purposes. Having a higher bit rate, a higher quality, near lossless for archival purposes. So you get unmatched compression and processing speed and no exotic hardware. Commercial, carrier grade, commercial off-the-shelf hardware. Then I think what we'll do is we'll do a second webinar to talk about Perseus Plus, where Perseus Pro is for contribution. Perseus Plus is more for distribution or over the top. So in the way that Perseus Pro does this down converting and up converting, Perseus Plus sits on top of industry standard codecs. So an H.264, an HEVC, VP9, AV1, and it sits as a secondary channel, and it looks for the error. It compares the H.264 compression to the original content, and in a loop comes up with that different signal, that error signal. So it analyzes and it adds extra clarity, extra resolution to industry standard codecs out there. And there's no need to change your existing architecture. If you have IRDs or decoders, you don't have to throw them all out. If you are streaming to mobile devices, Perseus Plus could sit in the background as kind of a supercharge for the existing infrastructure, the existing stream. So we'll talk more about that in an upcoming webinar, but that's more for distribution and over the top. I'm sure most of you know who VidOvation is, but I'll give you a quick overview. VidOvation, we work with a number of different partners, similar to VNova. We work with AviWest for bonded cellular, AB on air for wireless, Multidyne for fiber optics, and a myriad of other partners. VidOvation, we're a video transmission and distribution company. Our tagline is moving video forward, so we help our clients move video from point A to point B for live contribution and distribution. We work with broadcasters, news networks, sports leagues, corporations, enterprise, etc. We provide consulting, design engineering, system integration, project management, warranty, and support. And you can see some of the names of the companies we've been working with lately, such as CNN, Turner, Fox, the NFL, Viacom, A&E, etc. Do you folks have any questions for us? Let me see if any hands have been raised. Maybe not. Let me see. No, it doesn't look like there's any questions. So folks, we thank you for tuning in today. You can see my contact information. You can reach VidOvation at 949-777-5435. That's our phone number. You can reach our sales department at sales@vidovation.com. You can reach me at JIMJ or JimJ@vidovation.com. And we'd love to work with you or answer any further questions you might have. Thank you so much, and look for a recording of this webinar online sometime in the near future. Thank you so much, and have a great day.